Okay, let's talk about acids and bases. The easiest way to understand the nature of acids and bases is by absolutely going into examples. In here, we can see that under the word acid, we have HCl. So this is a hydrochloric acid. It has hydrogen and chlorine. Hydrochloric acid is a common strong acid, and when you dissolve this into water, hydrogen is added into the solution. So this is an acid because it can share this hydrogen ion. Now, on the other hand, when we look at the bases, we can see that bases, instead of just the hydrogen, they had this OH group. So this particular base is sodium hydroxide, and if you put this sodium hydroxide into water, this chemical substance can share this OH group. So that's why this sodium hydroxide is a base, because it contains this specific OH group. Okay, so the first quality or the first characteristic that we will distinguish for acids is that they can have or they can share hydrogen ions into a solution. Bases, of course, they will do the OH groups or hydroxide groups into the solutions. Both acids and bases can be bitter, sour, and slippery. Both of them, bitter, sour, and slippery. But only acids will react with metals. Another characteristic that can help us differentiate between acids and bases is the use of indicators. So let's imagine that this little rectangle that we have over here is an indicator. This is called litmus paper. If this indicator, called litmus paper, is in contact with a base, the paper is going to turn blue. On the other hand, if this litmus paper is in contact with an acid, the paper will become red. So you can easily use litmus paper to help you identify if you are in presence of an acid or a base. But how do we measure how strong is the acid or the base? Well, for that, we have what we call the pH scale. Right here, in the middle, we have number 7. This is a scale that goes from 0 to 14. Right in the middle, we have the neutral pH. Neutral means that it's not an acid nor a base. So the closer you are to the neutral area, the weak you are. So imagine that you have an acid with a pH of 6 and another acid with a pH of, let's say, 1.5. Which one is stronger? In this case, the acid that is the strongest of these two is going to be the one with 1.5. This number 6 is so close to the 7 that is very, very weak. It is very close to neutrality. So the pH scale is used to determine how strong an acid or a base could be. On the other hand, anything that is above 7 will be called a base. And the rationale is the same. The more far away from 7, the stronger you are. If you have a base with a pH of 13 versus a base with a pH of 8, the base with a pH of 13 is going to be the strongest. I am using the blue and the red color on purpose. Remember, anything below 7 is an acid, and if you have litmus paper in the presence of an acid, it will become red. But if the same litmus paper is exposed to a base, it's going to become blue. So that's just another thing to remember. But why is this important? Well, knowing that you have a strong acid can help you predict how this acid is going to dissociate into water. So if you have a strong acid, it's going to dissociate completely. And the same way, if you have a strong base, it's going to dissociate completely. Total dissociation, 100% dissociation. That's why it's important to know if an acid is strong or weak, same with a base. So if the acid is weak, it's not going to dissociate completely. Otherwise, if it is strong, you will see 100% dissociation. And you can actually prove if you are in presence of a strong acid or a base. If you, let's say that you are placing a strong acid, even a strong base, in this water, this is a beaker, it contains water, you place a strong acid, also works with a strong base, because you know that if it is strong, it's going to dissociate completely. You will have a lot of ions in this beaker, right? Because everything is going to dissociate. So if you have lots of ions, this water will become very conductive. So because you have a strong acid or a strong base, this is going to illuminate very well because you are closing the circuit, right? On the other hand, if you don't have a strong acid or a strong base, well, if it is weak, you will see only some dissociation, not as much, and the conductivity is not going to be really high. So you will see just some illumination right here because it's weak. This water is going to be still well conduct electricity, but not very well. Remember, if it is strong, you will have a lot of electrolytes in here, and this water will become a very good conductor with strong acids or strong bases. And this is going to be very illuminated here strongly, okay? Because you have a strong acid or a strong base inside of that solution. I hope this review helps.